Okay, in this video we're going to go through a couple of the homework problems. This is from section 7.1, so we just did the notes on the interior and exterior angle theorems, so I'm just going to write them up here. So, well, I should write some of the interior, sorry. Let's write some of the interior angles of a polygon. And that was equal to, right, the number of sides minus 2 multiplied by 180. And then the sum of the exterior angles was always equal to 360. So watch the previous video if you feel like you have questions about those. Okay, that's degrees. So looking at these exercises, I just want to talk about kind of how we use these. So again, in geometry, questions that we ask ourselves are, one, what are they asking me to do? And then based on the shape or the picture or the diagram that's given, what can I use that I know to help me find what they want me to find? So for example, number 11, the instructions just say find the value of x, right? And number 12, I'm going to look at number 12. It doesn't tell me anything else, just find the value of x. So if I look at x, I immediately am thinking, well, x represents an interior angle, and it looks like they've given me other interior angles. So the only thing that I know is that if I knew what these should add up to, then I could figure out what x should be, right? So remember this is where I would immediately think, okay, sum of interior angles, and it has 4 sides. So there's 4 sides, right? That's the number of sides, minus 2, 180 degrees. So this should equal 2 times 180 should be 360 degrees. All of these added up on the inside should be 360 degrees. So again, I know that if I take 360 degrees, right, and subtract out these ones, that would be what was left over. So you can either set it up as an equation and say 103 plus 133 plus 58 plus x. All of those should add to 360. And then it essentially becomes a subtraction problem, and you're just subtracting those values out, okay? So let me just, I'm going to plug that into my handy dandy calculator here. Again, 103 plus 133 plus 58, looks like it's 294, and we subtract whatever that is by 360 to end up with 66 degrees. And again, I always just look back to make sure that looks like it could be about 66 degrees. At least I didn't get an obtuse angle, right? So again, we're just using what we do know to find what they have asked of us. On number 19 and 20, so I'm just going to look at 20, it says find the measures of x and y. Again, it doesn't give you any other information than that. So you look down at your diagram and you think, okay, well, again, we're on interior angles. So I think I'm going to deal with the interior angle theorem. This one has 5 sides. So if I have 5 sides, thinking back to my theorem, 5 minus 2 times 180 is 3 times 180, or in other words, 540 degrees. So the sum of these ones should be 540 degrees. I know W is 47 degrees. I know that V is 119, and Z, that symbol, right, means 90 degrees. Now Y and X are both labeled with one little arc, which means that they're equivalent. So this is going to be whatever the same angle measure as this one is. So you can think about it algebraically and set these up as like little x's, and that would mean that 47 plus 119 plus x plus 90 plus x, right? All of those have to add to 540 degrees. Or in other words, if we take 47 and we add 119 and we add the 90, those like terms, we get 256, and then I have these 2 x's, right? We subtract the 256, and 2x is equal to 540 minus the 256 would be 284, and then we would divide that by 2. So each of those angles, right, the measure of angle x is 142, and the measure of angle y is 142 because they're equivalent. So we know that those are the angles. Okay, so again, we're just using what we do know to understand the notation about what they want us to find. Jumping down, let's look at exercises 27 to 30. This says find the measure of each interior angle and each exterior angle of the indicated regular, remember that word, regular polygon. So regular means they have the same side lengths. And in turn, that means that they have the same angle measures all the way around. So if you think about it, if I have, and I can't draw these very well, but if this is a pentagon, oh yikes, and they're all the same length, they're also going to have like the same angle measures all the way around, because none of them are ski-wompy, kind of like my picture looks. So let's just look at one of these, and maybe I'll look at number 28, let's look at 28. So number 28 says it's an 18-gon. Now think about an 18-gon. If I want to find the measure of the interior angle, one of them, right? First of all, I should probably figure out, well, what would the total be? And then we can split that evenly between the 18 angles. So first of all, I use the sum of the interior, which again is n minus 2 times 180. So I take 18 sides and we subtract 2 and we multiply that by 180. If we take 16 and we times that by 180, we end up getting 2,880. And that's weird to write commas in my degrees. I don't know why, but it is. So we end up with that. And again, if I want to split that evenly into the 18 angles on the inside of my polygon, then I just take 2,880 and divide that by 18. When we divide that by 18, then we end up getting 160 degrees. So if each of those are 160 degrees on the inside for our interior angles, then they would add up to that 2,880 degrees. The exterior is a little bit easier because the exterior angles are always 360. So I just have to take 360 degrees, divide that evenly into 18 pieces, and an exterior angle is just going to be 20 degrees. Okay. Another way to think about that is if you have any sort of polygon, let's just use the one that I have up here at the top. If you know the inside angle, so remember 1, 2, 3, 4, 5, pentagons always add to 540 degrees. So if I divided that by 5, so 540 and divide by 5, each one of those would be 108 degrees. So this guy in here, right, would be 108 degrees and all of them around. And its exterior angle, boop, 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 we'll just extend that, would be this guy right here. So they're just linear pairs. So 180 minus 108, right, is 72 degrees. So those would be the exterior and the interior, just like these ones down here are linear pairs. They both sum together to give you 180